Okay, today we look into chapter 2. We start to look at one equation only, which is kinetic of particles, force and acceleration. This chapter, we will look at F equal to ma, or all the force will equal to all the mass and acceleration. F equal to ma. Today, the whole chapter 2 will only look at this equation. All right. So three parameters involved in this chapter 2, force, mass, and acceleration. Okay. A kinetic chapter, for kinetic subject, we start with displacement, velocity, acceleration, and time. So same, you need to use chapter 1, what you understand in chapter 1, apply in chapter 2, where now we look in one more component, which is force. Okay. So you learned about this F equal to ma previously in statics, right? This equation is called equation of motion. So just an introduction to gravitational attraction, which is a G. So on the Earth, if we talk about vacuum, so we have two mass, which is Earth M1 and the satellite M2, and the radius between the Earth, center of Earth, and the satellite is R. So we can use this equation to calculate the force required to keep our satellite in the orbit. So we can use F equal to G, M1, M2, and divided by R squared. Okay. The G is the constant value, which is a universal constant gravitational. So on Earth, between Earth is 66 10 power negative 12 meter cube over kilogram second square. Right? M1, M2 is the object mass. Then R is the distance between the two. Okay. So this is gravitational attraction apply when you talk about astrophysics and so on. Right? Okay. So let's substitute the M1 as ME. Then your equation will become M and capital ME. And we know that our weight equal to mg. Okay, F equal to mg. So if you equal your force and weight, and you pull your m to outside and pull your g to inside, okay. So your g will equal to g me divided by r squared. So this is more on the astrophysics, but again, we for this module, we don't go into this section, but it's just an introduction to you. This equation can be used for most of the dynamics motion, including anything that move in the space. Means in planets that have gravitational effect. Okay, so example, this one. This one is more on in aerospace or astrophysics, when you deal with planets or object that moving in the vacuum. Okay. Okay. Right. Now on the Earth, what we observe is the weight and acceleration. The weight is mg. So start from today, all the weight will equal to mg. So you can either use capital W to represent mg, or in your free body diagram, you can use mg. Right? Unit is Newton. Mass is in kilogram. So unit SI used for this module is kilogram. acceleration will be in meter over second squared. So this is a vector diagram that you should be already familiar. So you have two vector F1 and F2. The combination between F1 and F2, you will get resultant force, and you can draw a diagram like this. If the two forces is 90 degrees, you can use this approach. So when you write the forces, you can write resultant force will equal to F1 plus F2. This is a vector equation. Okay. So introduced today in chapter 2. Every time you draw a diagram, nowadays in static you only have one diagram, but for engine dynamics you have two diagrams, which is on the left hand side. On the left hand side you have forces. On the right hand side you have MA. Forces, they are called free body diagram. On the right hand side, they call kinetic diagram or kinematic diagram. In this case, we call kinetic diagram. Why kinetic? Because you're dealing with acceleration. Okay, you're dealing with acceleration. Mass, normally it won't change. Okay, normally it won't change. So of course, you deal with mass and acceleration on the right hand side. So you have two diagrams that you need to consider when you do chapter 2 analysis. Okay, so this is the first diagram, but it's important for chapter 2. Okay. Okay, so F equal to MA again is very important. F equal to MA. Okay. All right. Those latecomers, watch back the video. Later, don't ask me, hey, sir, why this one, why that one? I already explained why we use a certain equation. Okay, now in this case, in chapter 2, we start to have your position again. We need to have a reference point. We need to have a reference point. So we always start with a reference point O, and then to the right is X, moving up is Y, and then we have a path in particles. In chapter 1, you deal with linear equation, you deal with quadratic equation and polynomial equation. All right? So we assume you already know how to draw the path and basic kinetic motion for the velocity, acceleration, and so on. Okay. So if you have this one is in the just a introduction to how you make your references. Okay, your velocity and so on. Velocity and acceleration. Okay, the rest you read from the slides. So this slide is just to highlight that acceleration now you are measure from the reference that you put in your this one. Okay. So now you learn about particles. In later chapter, when you learn about rigid body, you sum up all the force. So these are all the particles, small particles. So each particle, when you group them together, you get the sum of the force. Okay. So what is important is that when you draw free body diagram again in chapter 2, there's two sections in your free body diagram or in your drawing. On the left hand side, you draw free body diagram. On the right hand side, you draw kinetic diagram. So as you progress more, you will combine these two, but in your analysis steps, you should be able to separate between the two. So for the starting, we will split the two from the left hand side and right hand side for you. But as we move further and further, we will combine these two in one diagram. So on the left hand side, you always deal with the force. On the right hand side, you deal with the kinetic. Okay. Again, we still haven't run away from F equal to ma. Still, you sum up all the force equal to mass and A, right? It means you sum all the force, you sum all the mass, multiply by the A. So this one, mass and A, you look at one dot or one particles, then you sum up all the MA together. Okay, so this chapter also tell you that when you combine mass and acceleration, you will get force. When you combine mass and acceleration, you will get force. So again, in your lab report, there is two stations that you deal with velocity and acceleration. So for that two at the back, that use computer and the two sensor, station A, station B, that one, you need to apply F equal to ma equation in your analysis. Okay. So the rest you read. What is important is the application. Okay. Okay. So I want to highlight this one. When you see the notation of G in my slides later, it means that you calculate from the center of gravity. Every mass on the Earth will act on the center of gravity, which is one dot inside there. In your static, you call it CG. All the acceleration will act on this point and go down. This is called weight, which is equal to mg. When you deal with gravitational force, it always go to the center of gravity or center of mass. Center of mass. Okay, it's called center of mass. Okay. So in your foundation or in your secondary school, you know how to find the balance point or center of mass for the object. Okay, in statics, you learn about Ixx, Iyy, Izz, all these things. So you did learn all these things already. So we assume you know how to find Ixx, Iyy, Izz, and so on. Okay. All right, in three-dimensional, still the same. We still deal with all the force equal to ma. Okay, so you can break into x, y, and z again, like what you see in the chapter 1. So again, left-hand side is force, right-hand side is kinetics, motion, F equal to ma. So F, Y, Z, and then X is I, Y is Z, Z is K. And you see, if I deal with one object or one dot or particles, I only have one mass, but I have three acceleration components. Okay. Those come late one, please go and listen to my recorded video. If you come late and you don't understand, please don't ask the things that I already covered in the previous 10 minutes or 15 minutes. Okay. All right. So the analysis is you draw the diagram, you write F equal to ma, then you look at what are the force you have on the left hand side, what are the acceleration magnitude that you have on the right hand side, then you combine them, you analyze based on x direction. So x, you do x analysis, y, you do y analysis, z, you do z analysis. This is how you do in chapter 2. So chapter 2, you look at one direction, one direction, one direction. Okay. In chapter 1, what is the difference from chapter 2? Chapter 1, you sum up all this, you square this one, square this one, square this one, square root. This one, you also square this one, square this one, square this one, square root. But in chapter 2, you break them, you reverse the steps. You break them into x, y, and z. Okay. Now we look at the first example. So you have an object. In this case, we are still in particles chapter. Later in rigid body, we'll look at another things. So chapter 1, for example 1, you have an object of 50 kilogram rests on the horizontal surface with coefficient of kinetic friction mu k, right, equal to 0.3. If the crane is subject to 400 Newton forces as shown in the figure, so you have a degree now, you have an angle there, determine the velocity of the crane in 3 seconds starting from rest. Okay. Now, in your experiment, one of your experiment, you find friction on the plastic and wood. So in this case, in the experiment, you find mu s and mu k. Mu s is the friction that just enough to make it to move. Mu k is already in motion. So this one, you expect to move already. If you use mu k or kinetic friction, means the object expect to move already. So for engine dynamics, we rarely consider what you learn in statics. Whereas in static, you use mu s. In engine dynamics, you use mu k. Okay. So how do you solve this question? Right? It asks you about velocity. Okay. So what you do is that you draw free body diagram first. Okay. Again, since the beginning of the class, for today, I already tell you how to do the things already. First, you write F equal to ma. Then on the left hand side of your diagram is all the force. On the right hand side is the acceleration. So what you do, you draw your drawing board into left and right. Left hand side is all the force. Right hand side is all the motion. Okay. So the name for the left hand side is called free body diagram, which is you learn in your statics. In engine dynamics, you learn more additional information, which is called kinematics or kinetics diagram. Okay. So you put all the force on the left hand side diagram. So in here, you have a force, only have one force, which is P, which is 400 newtons with 30 degree. And start from chapter 2, you need to consider gravitational force already, which is always acting from the center of the object. Always move at the center of the object. So if you're given a car, no matter what is the shape, so start from chapter 2, if the question come out, it give you a force to the front, anything, remember in your free body diagram, go to the center and draw this width force in your free body diagram. Okay, this is the additional steps that you need to take note. Every time you draw free body diagram, you copy all the force that given in the question. Next step is go automatic, go and find one dot on the photo or in the picture for that moving object, add the weight, go down straight because of gravitational force. Okay, W equal to mg. Okay. Again, this is particles. Particles means we look at one dot. When you have one dot, it will always go to the center of the object. In later chapter, when you learn about rigid body, then you have a combination of body 1, body 2, body 3, body 4. You need to find the center point of this group of projects, this group of body. Is one in later. But today we just assume everything as one particles. So we assume is at the center of the object or center of mass. Okay. So this one later. Just introduce you so that you get prepared in later for kinetics. Okay. So far, everyone understand, right? This one. Okay. So now, because the question already start to give you the friction. So friction, what is the equation for friction? You learn in statics. F friction equal to mu n. So it depends on whether it's static or kinetics. You are learning dynamics now. So you are having kinetics If it's moved, if it moves in the experiment, you do two experiments, right? One is mu s, one is mu k. The load that is start to move the object is called mu s, mu k, which is kinetic friction. If you mu s is called the things that it just to maintain in equilibrium, the object in equilibrium. Okay. Okay. You will see these mu s and mu k in your assessment. Right. So again, this NC is the direction of the normal force. Direction of your normal force will always 90 degree to the surface. This normal phase will always 90 degree to the surface. If your object like that or like that, your object like that, where's your end? Your end is like that, always pointing up and 90 degree to the surface. What if you have a straight the object like that? Your normal force is like that. So this end, okay, Dr. Ang, where should I put this end? Or what kind of question should I put this end? So for engine dynamics, as long as you have two objects touching each other, or there's a surface is touch, they always an end. As long as it's touch, either it's a round body. If you're a round body, where there's the round body touch, one point here. Where's the end? Here, 90 degree. Tangent to the curve. Yeah, and is always there when there's a contact surface. Right? Important, this one. This one also is one of the area of careless mistakes from the student. So when it comes to assessment or final exam, you'll be panicked. You do all the things, you know, or you should put W, but you do, you forget this one. Okay. Right. Then N, once you have an N, you always have a friction, right? So all these equation won't be given. We assume you already know what is the equation for friction. Friction equal to mu N. Okay, mu N. It is the kinetics friction coefficient multiplied by the normal force of that object. Yeah. Right. We have done with all the force. So for the force diagram on the left, you're dealing with all the force. So from this example, what is important, what is usual practice, all the force diagram, MA. So in the left-hand side diagram, you deal with force, then we deal with N, then you deal with friction force. If there is any contact, means that there will be N. If the free fall object, there is no contact. Free fall, they only have a drag or air resistance. Okay. And what else is missing here? What else is missing? What else is missing here? You have F, you have N, you have friction. What else? Gravity will contribute to what? With these four are the usual members for the left-hand side diagram. Okay, remember. So this one is the important one. You miss one, then you in your calculation later, either your value is wrong, or you will be stuck. Where is my friction, or how do I find friction? Okay, kinetics means you predict how this object moves. So if you pull at 30 degree, this object will move to the right, right? Or move to the right or move to the front. So if you slide this one as what you did in your free body diagram, You slide this one, so you move to the right. Right? So you write an arrow, you move to the right, and you move in the right, and then you write MA. Combination of M and A give you force. Combination of vector A and mass will give you force. You will generate force. So F equal to MA or MA equal to force. Okay. So once you have the diagram ready, you group them into X direction and Y direction. Okay. So equation of motion, you look in X direction and Y direction. So all the force in X equal to mx. Can you group the force together? Let me group the force in X. What are the force belong to X? Friction. This is not X. This is not X. So this one, there is an X component. You need to split this one into X and Y. Okay, split this one in X, so it become cos or sin? Cos. So cos 400, cos 30, 400, and mg. Sorry, not mg. Friction, mu s n equal to m ax. Okay, so this is the first equation. Second equation for y direction, nc go up positive, w go down negative. Positive, negative, important. Nc go up positive means all the motion go up positive, go down negative. So nc minus w. Then what else? This one, this one go up. So 400 cos sine 30 equal m what? MAY. What is your MAY? What is your AY? 0. There's no AY component. You split also your AY 0. It's 90 degrees. Okay. So when you group the two, important is F equal to MA, you split into XY. If this is three-dimensional, then you have one more, which is Z direction. So you have all the equation. This one, MAX, will give you, this is the constant value. 400 cos 30, you can get one constant value. 0.3 NC and 50 A. You don't know your A. You don't know your NC, but don't panic. Find your answer in the next equation that from the Y direction. So if you do the equation, 400 sine 30 minus 550, 9.81 plus NC equals 0. So the second equation here give you one unknown, which is NC. So once you find your NC, you substitute back here, you're able to find your A. Okay. Yeah. Okay. Now once you have this one, you get your NC equals something. And then you substitute for A, you get your A equal to something. Important is the unit. Important is the unit. Okay. Next, he asks you about velocity. If I ask you about velocity, in this case, your acceleration is constant. Okay, the acceleration is constant. So when the acceleration is constant in chapter 1, you have three equations you can use. You have three equations. V equals something, V squared equal to something, delta S equal to something. That three. Okay. So in here, you have A. You want to find velocity. So there's one equation that is with V, U, and A, and P. So time, you don't know. What time you have? 3 seconds. So recall the 3 Newton equation. V equal to something, V squared equal to something, delta S equal to something. So you try out which one that will help you, right? So this one you are given t, you are given the initial velocity with its rest. So you have your u or v naught plus at. So you have your v naught, you don't know your final velocity, you have your acceleration, you have your time. So in this case, the first one will help you. Because the another two you are dealing with displacement. Okay. Substitute, you get your velocity. And direction is to the right. This is a vector. Velocity is to the right. Make sense, huh? Okay. Now recall what are the steps that we do. First, you look at the question, it gives you friction. Sure, it's chapter 2 question already. You see the question, it gives you friction coefficient, either mu s or mu k. It's chapter 2 question already. So chapter 2 question, straight away go to your answer sheet, break into half, left hand side F, right hand side MA. Or you in your answer you write all the force equal to MA, you get 1 mark for that equation. All the force equal to MA. Then break into half. You're working break into half, left hand side and right hand side. Left hand side you draw free body diagram, all the force you put inside that body or that particles. Right hand side, you only deal with motion. You predict where does this particle move. For example, this example one, it moved to the right. So on the right, you draw an arrow and then you write MA on the right hand side diagram. Okay. Left hand side, free body diagram deal with the force. We already mentioned the 4 important members. The force in the question, the normal force. If there's any contact between the body or on the surface, there is a normal force. What is the purpose of finding normal force? It helps you to find what? Friction force. Without the N, you cannot find friction. So as long as there is a contact, there is a friction. That is a logic. Okay, then you don't forget about the gravitational force. They always have a W weight acting on the center of mass of the object. So these 4 parameters, don't forget. Always check your free body diagram on the left. Do you have the force or the force given by the question, the normal force? If there any contact, then put the normal. Friction and normal. So for example, the one I draw on the whiteboard here, this car have 2 wheels, not 4 wheels, but in 2-dimensional, you have 2 wheels there. Okay, so there is a 2 contact force here. This one contact, this one contact. So you have N1 and 2. Okay, this kind of question come out in final exam. And also, I think test 1. Or test 1 or test 2, I forget it. Okay. As long as there's 1 contact point, there's 1 normal. Unless the question asks you about wheels one, you have 2 it depends on where contact, especially round bodies, they have 1 contact surface. If the whole surface is touching, then we only have 1. Okay. Let's look at number 2. Number 2, it tell you fire a cannon from a horizon, from a floor. You move up with a Z, and the cannon ball is 10 kilogram vertically upwards. So in this case, you know already this is no contact kind of question. So there's no N there. Right? There's no N in your free body diagram. So determine the maximum height, which is what we travel. First scenario, you ignore the friction from the air resistance. Second one, you're given the friction force, which is 0.1 V square Newton. Okay. So how do you work with this question? Again, when you see this question, how you know this question is chapter 2 or chapter 1? So chapter 1, you don't see force one. Chapter 1 question, you don't see force inside the question. You deal with what? Chapter 1, you deal with displacement, velocity, acceleration, time. That is chapter 1. Then when you come to chapter 2, you start to deal with force already because F equal to ma. So in the question, if you see force, anything inside there, you see a force, F force there, then it's chapter 2 already. Chapter 2 and onwards. Okay. First, you draw free body diagram. You know that this is chapter 2 question. Straight away, you write F equal to ma, you get 1 mark. Not right here. You write here. All the force equal to ma, you get 1 mark. Without anything on your answer. You write question 2, like for example, question 2 or chapter 2 question, you write all the force equal to ma, you get 1 mark. Even though you don't know how to answer, you write F equal to ma, you get 1 mark. Okay. Free body diagram, break into 2, like the same, left and right. So what does we focus on? Do we focus on the body of the cannon or the ball? The ball, right? So you draw the ball. You draw the ball. What are the force you have on the ball? What force? F1. What else? G. Okay. W. W. G is not force. W. What else? What else? You have 2 scenarios, right? One is without, one is with, right? So you have friction force, right? You draw a cannonball. There's a force that continue it moving, F1, and there's a weight pulling it down. Where's the friction force? Going in, how you draw friction force? Up or down? Why down? Opposite direction of your motion. Look at your motion. Your motion is going here. Okay, but you don't draw motion in the left-hand side. Left side is force. You draw the motion on the right. Okay. So this is what you have in there. So it tell you it projected up. Why there is no force? Why there is no F1 like what we discussed in class 5 minutes ago? Why there is no F1 here? Why there is no force in the cannon here? Why? 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 This is not a rocket. Rocket have a fuel eject out. There's a pulling force or there's a pushing force from the vehicle or from the object. This one don't have anything. It shoot out because of the inertia. So there is no force there. So don't go and add the F1 in front of the object. You need to look carefully at the diagram. If it's a rocket or there is a vehicle, there's an engine. You mentioned engine that makes a thing move, then there's a pushing force. But this one don't have. Okay. All right. So yeah, F equal to ma on the left hand side, go up. So from here, you can make the equation already. F equal to ma, break into x and y. In this case, your x is 0 on the both sides because no x direction. You only have y direction, or in this case, you are given z. So please use z in your equation. If you see the question give you z already, your y, F equal to ma. Previously, you see y here. But this question give you z, please change the y to z. Don't, if this kind of question come out, you write y equal to ma, I will put a question mark there. Where is y? You need to stick to the question. Don't just memorize one and then go into the exam. Look the question. Okay. So here you modify a little bit to the z. Again, direction is important. You see your class mistakes that you will do. If you're not careful, you'll put positive. this is go down negative. You're dealing with vector. Force is the vector. Okay. So in this case, this is W. So to be safe, in your free body diagram, always draw where is your positive, negative. Put somewhere in your diagram, tell yourself where is positive, negative. Or you can just put beside the diagram, you draw Y and X, where is the positive. Then in your equation, when you derive, don't so, this is just a quite a very fast process. I will recommend you to use the W first, then only you write mg. Okay. So in this case, it's minus W, which is minus mg, equal to ma. Okay, so you can cancel because in this case, the mass doesn't change. So you can cancel both sides. Your A equal to minus G. Okay, it's minus G, so 9.81. So the answer for acceleration will be minus 9.81. So again, the acceleration in this case is constant. So you can use back the 3 Newton motion equation. Right? So in this case, because we know the displacement of position, which is delta S, so there's an equation of V squared something. Use that equation. Because you don't have time, you only have position. So there's one of the equation that can help you. You know the initial velocity, right? 50 meter per second. So that you know your initial. You already calculated your A here. A is negative. Right? Z, you know the distance between Z. Okay, Z you don't know. The question tell you to find. So V you know, right? Maximum position. What is the V? 0. So 0, this one you know, 50, there's only one unknown. So for there, you find 0. You find the Z. So in fact, you already teach you how to solve this one in the chapter 1. Okay. But in chapter 1, we use rocket with the force, right? Okay. First case, we don't have the friction force. Second case, we just modify a little bit your free body diagram with the FD. And by now, you should be able to understand why FD pointing down, because it's opposite of your motion. Your cannonball moving up, so friction is always opposite. So the same, it's the same, but again, be careful on the positive, negative sign. Force is a vector. Your weight also is a vector. So you already define go up positive. So negative, negative, equal positive MA. Okay. Don't confuse with the A. This one, confuse. Some of you might confuse A here with the positive and negative sign. Yeah. Because once you do the A already, or in your mind, like you store the negative A in your mind. No, don't do that. Don't do that. Just stick to your free body diagram. And then you try to solve with the equation F equal to MA. So you're given FD in this equation. So minus, again minus because it's go down. Minus FD minus W equal to MA. Now for engineering dynamics, usually we don't substitute value first. We will derive equation first, then only we substitute. It's very dangerous to substitute value in the engineering dynamics question. You derive equation first, then only you substitute. Okay. So you solve the question because the only unknown here is your acceleration. So your acceleration change. Your acceleration change. In this case, you have two unknown, A and velocity. Right. So when you get this equation, then in this case, it's not constant. Okay, the acceleration is not constant. So these three equations here cannot be used. Acceleration when it's not constant, this one cannot be used. Okay. So there's another equation you can use from the chapter 1, which is definition of A and V. V equal to ds dt, A equal to dv dt. You freeze the time, you can get the as equal to v dv. Okay, this is how you use the A ds equal to v dv. In this case, you change your s into z. Yeah. So this is, I need to highlight this one because also we like to ask you questions something like this, right? So don't assume all question is with a constant acceleration. Huh? You need to check your acceleration whether it's constant or not constant. Okay. You need to split yourself with the statics and engineering dynamics. Huh? Statics, all your acceleration is constant. But in dynamic, it will not be constant. Okay. So once you have that, you substitute what is your A, because in the previous section, you define what is your A in V term. You substitute your A over here, dz, V dv. So what the next step is that you move your V to one side, one V to one side. Okay, so you just, and then when you do integration, you know that you have dv, d something, you know you need integration. Integration, you need boundary condition. You need lower limit, upper limit. So in this case, what you know, when your z0, your velocity is 50. Okay, when you reach z, when you reach maximum height, okay, when you reach maximum height, your velocity is 0. In this case, the maximum height might be different from section A, because section B, you consider friction force. So A, the height of Z will be higher than the case B. Right? So if you get your answer in your height, maximum height, B is higher than A, then something wrong already. Okay. What is your answer? What is your? Oh, okay. The question is what? Then what is this? Let me see. Maybe some typo error in my slides. Okay, I think typo error. No, no typo error. Do you see how you transform this one to this one? Because you already divide 10 here. You move this 10 to right hand side, left hand side. No, you don't in this when you do analysis, you don't mix with the free body diagram anymore. You just substitute. You already do negative here already, right? You don't confuse with this side. So this side negative, you understand, right? A, why this one positive? Why A is positive? It's going up, what? Motion going up, what? So why you have a negative? You already consider mg go down already. Why you have negative? This one whole thing, you just substitute the value for the gravitational. This one, you see this one as as capital W, mg. You just substitute mg here. The g is here. So if you bracket this one negative 9.81 means your W is going up already. Yeah. Okay. So you continue to find the answer. In this case, the second boundary condition Z here is Z. You don't know how high it has to just things that you don't know. You just put inside the one parameter there. Z. Okay. Then you do integration. When you do integration, move the same term together. For example, V should put V together. Z put Z together. Okay, rearrange. This one put to this side. Okay. So you pull this one. This is a bracket. So you pull this one to the right hand side. You will see dz on the left. And v dv divided by bracket this one. You just carry the negative along together. So that's why there's a negative sign here. Okay, then the next step is integration chapter already. That one you go and find your mathematics textbook. Okay. Okay, you do your integration. Okay, this is your homework. Go and do your integration. How to do it? Go and find out. So you find your z equal to 114. This is a reference answer. But what is important for the today first session is that you try to observe what are the SOP in solving problems. First, write F equal to MA. You read the question or got force, you write all the force equal MA. Get 1 mark already. Second, you look at the question, split into half. Left hand side is force, right hand side is motion. Okay, you can use your pencil to write free body diagram. On the left is force, the kinetic is MA. So you draw the object. On the left hand side, you only deal with 4 things. Force applied to the object, or the force lah. Then if it's contact, then you have contact normal force, N. So what is the purpose of finding N? To find friction. F equal to mu N. Then another one is the most important one. All object must have mass. Mass acting on the gravity, it will give you weight, mg. So this 4. Right hand side is always MA. Right? Always MA. So MA is you look at how it moves under the force. And combination of MA give you force. Yeah. Okay. Okay, we go for one more, then we have a short break. Okay. Now, example 3. I think you're still fresh, right? When you see pulley, it's not necessarily chapter 1 question. It can be chapter 2 question. Okay. Chapter 1 question, you only deal with velocity, acceleration, time, and position. If the question asks you about force, it's chapter 2 question. Okay. So, and how you know it's chapter 2 question or chapter 1 question? When you see mass given. In this case, although you see there's a pulley here, but in the question you're given mass already, 100 kilogram or something. So you're given mass is chapter 2, F equal to MA already. You deal with force, you deal with mass, with the acceleration, right? So 100 gram A released from rest, if mass of pulley and the cord ignore, determine velocity of 20 kilogram block B. So when you see mass, it's under chapter 2 already. Okay, so in this case, you see this diagram. First, this is a pulley question. Pulley question, you look at your datum. Important, look at datum. Datum for B is go down positive. Datum for A go down positive. Look at the datum. Second, look at the rope. How many rope you have? You only have 1 rope here. Although this one is constant. This one doesn't need to be calculated. The only 1 rope that make the A and B move is this rope. Okay, so when you have deal with pulley question, straight away go calculate the total length of the rope. How to calculate total length? SB plus SA plus SA. So you have 2 SA. So LT equal to 2 SA plus SB. Then convert this one into velocity and acceleration. How to convert your distance to velocity? V equal to ds dt. Time differential this one. Okay, time differential this one. The whole equation dt. Total length, does it change or not? No, 0. SA become VA. SP become VB. Now you know the relationship between A and B. You move this one to left, you get negative, right? So then A also same. You continue to dt. What is A and V? A equal to dv dt. You time integrate this one. 0 still get 0. A become V become A. Okay. Right. Now, if you look at this diagram, block A is 100 kilogram, block B is 20. So which one is pulling? A is pulling. A go down. When A go down, B go up. So basically, two are moving in a different motion. That's why in your calculation, you should see VA, VB will be negative. Between A and B will be negative. Okay. So first, we focus on, okay, beside that one is chapter 1 analysis. That one chapter 1 analysis. Second one, when we come to chapter 2, again, repeat the same process. Left-hand side, right-hand side, F equal to MA. Left-hand side, you look at pulley number C here. Because you deal with force. Deal with force, and it asks you, what is the velocity of B? Velocity of B, why you need velocity of B? Why you need to find C? Because you need to find the force, the tension inside the cable already. You don't need to find tension cable in chapter 1 question. But when it comes to chapter 2, then you need to find forces inside there. Tension is one of the forces. So you look at C. C, you have 2 rope pulling up and 1 rope pulling down, right? Pulling down is what? Mass of A, right? So you have T and 2T. Balance, balance. So these two tension must equal to the tension over here. Okay. Then what is equal to 2T? What is equal to 2T? 100 times 9.81 or W of A. Okay. Again, don't substitute value first. Generate the equation first. All right. Now mass A equal to 9.81. So your T2 will equal to mg or omega A. Or sorry, WA or MGA. Yeah. Okay. So for mass A, your diagram will be all the force equal to MA. So the will have 2T and mg. Because you look at A, this one is pulling up, this one is going down. So you have 2 force. So anything that link with the body and is pulling with a rope or chain, there is a tension there. So there's additional information for chapter 2. When there's a contact, means where there's a normal force. When there's a connected chain or rope, then there's a tension on the body. Okay. So this one, you understand this one already, then you continue with the same thing lah. So just mark in the positive direction of SA, go down positive. I follow the datum. I follow the datum. Okay, you do for B, same. What is B? B, what is the tension pulling up? 2T or T? T, one T, this T earlier is pulling here, same, so don't confuse between the T and T, T and 2T, so when there's two rope here for A, two rope equal to 2T here, so this one it will only use one side of the rope. So do the same, F equal to MA, left hand side all the force we only have tension, cable, and weight. Right hand side is the motion. So B, in this case, B go down, we assume go down. Okay, we assume go down, because you, in this case, when you do analysis for chapter 2, you just see it as one body, and then when you let go, what happened to the body? You do that kind of analysis first. So I put my marking here as B go down. So you see, the previous one, A and B, what is the difference? So A is go down, I mark SA go down, SB also I mark SB go down. Once you have two body, you have F equal to MA diagram, you put them side by side and you try to solve the equation. Okay, you start to use F equal to MA. In this case, Y go down. So you only have one direction, which is Y. So you just read the information from the free body diagram. So in this case, they have two, but again, go down positive. Go down positive. So go down positive. So all the okay. So that's why here you have positive mg minus 2t. Okay, you might ask, hey, Dr. Ang, why now my direction is negative, go down positive? Because I don't want to mess up with my datum. I don't want to mess up with my general coordinate. Of course, in the previous example 2 and 1 and 2, your go up is positive. But when you deal with the datum question, don't mess up with the datum. Follow the datum direction. Yeah, this is the way you solve lah. So that's why you see the force for Y, I straight away a point go down positive. Then you group the thing together, you arrive at one equation, B and A equation. You do the same for B. You do the same for B. You get one more equation. Okay. Try to learn the concept first. This one you can get from the PowerPoint slides. Okay. Same for B, you get one equation. This one. Okay. Okay. So you have two equations. Two unknown. Two linear equations solving simultaneous equation. Solve simultaneous, you get T, you get, you have three unknown. A for acceleration for A, acceleration for B, and tension. So you have three unknown, two equation here. You need one more equation. That equation is from here. It's from the chapter 1, velocity and acceleration between two bodies. Okay. So this one you know already lah. Total length equal to what, and why we do not calculate the length here, and so on. Why we do not calculate the length here, and so on. Okay. So there you have the relation between A and B. So you have three equations now, three unknown, solving three simultaneous equations. Okay, then you find the answer lah. Okay. Then you find the tension and acceleration of A. So he asks you what is the velocity with the time. In this case, acceleration constant or not? Is the acceleration constant? Yes or no? Yes. Why? How you know it's constant? How do you know? How do you know it's constant? Because you're not seeing any quadratic equation like example number 2. You get one acceleration, one constant value, means constant value. If you get 3.27 plus something, then that one cannot already. 3.27 t, that one cannot already. You see equation over here, then cannot already. You see one value, then okay, you can use the 3 motion equation. So that's why I don't ask you to substitute value first. You derive equation, then you see what is the form. Okay, constant, then you continue. Not constant, then you cannot use this one already. You need to do integration. This one. You do integration if it's not constant. Yeah. So you have A and B, then you find lah. So in this case, constant, you use the 3 equation. In this case, you need to find velocity, you're given time, you have an acceleration. So be careful on what object is referring to because you have 2 acceleration there. So this one, it asks you about B. So you just pull out the B information. Okay. So in this case, you find negative 13 point something. And it means what? Negative means because your datum go down positive, you get negative, means the object move up. So it agree with your hypothesis and in logic also. Because you let go A more heavy, this one will go up. So it agree and is in the logical way, it makes sense. You do, you get positive, and then you see, positive, it means it's go down. It doesn't agree with the normal. Then something wrong with your positive negative sign. The magnitude may be correct, but the positive or negative might be wrong. Okay. So the question sometimes will ask you, what is what is the motion at the end? It will tell you. So you need to mention, if like in this case you get negative, you need to mention block B will move upwards. Okay. Okay. So can we go a little bit more? Then we end the class early. Yeah. All right. A little bit more, then we end maybe in the 5 minutes. So go a little bit more. So this one is addition to what you learned for your tangent and normal direction. Same. When you have a curvature motion, curvature path, curvature path. If this one moves this way, so you have tangent and normal. So same, tangent and normal, once you have 2 direction, you have force in that direction, force in that direction. Same, So in this case, in Z, we have a B means in 3-dimensional. Most of the case, I won't ask you 3-dimensional question. Right? Unless it comes to rigid body. Rigid body will have 3-dimensional. So same, F equal to MA. Then split into direction they have, like X, Y, Z just now. So you have acceleration in tangent, acceleration in normal. It's the same concept, but now because it's moving in the curve, you deal with normal and tangent direction. Okay, so you might ask, what is the difference between normal and tangent and X and Y? X and Y, normally the object move in a straight line. If you look at the question curve already, then you know you should go into normal and tangent solution already. So same this one you should able to digest it. Same Then force for B is 0 in this case when the object is moving in the plane. There's no force make it up. So this is automatic assume 0. Okay. Again, this is important. When we ask you a 2D question and or the question mentioned, it moves in the planar motion. Means this one automatic, we assume you know that force in z direction is 0. This one won't mention, we won't tell you FB equal to 0 or FZ equal to 0. We won't tell you. We only use the word, the object move in planar motion. Planar means 2D direction. So the third one will be 0. Okay. Look at this diagram, then we end the class. All right. So example 4, you have all the racing car and the racing track is slanted at a certain degree, and you move in a curved motion. You can look at the question. The object do not move in the straight line. It's not x and y. So you move in a curve. So straight away you think in the t and n direction. Okay. So you're given a banking angle, certain angle like this one. That's the diagram. Let's track so that the wheel of the racing car do not depend on the friction to prevent any car from sliding up or down. So this is a equilibrium question. Assume the car ignore the size, a mass m, and travel with the curve of radius r as a constant speed v. So basically, you convert the question into circular motion or circular pathway motion. You draw free body diagram first. In this case. Okay. So the T is moving outward lah. The T is moving outside the screen like this. Okay. Then the B is here. Then the object, the race car is slanted in this way. It's moving out from the screen. Okay. So first you draw free body diagram. In this case, in this direction, when you see from the front, there is only weight pulling down. When you see like this, so there's only one direction, which is W equal to mg. Okay. In the question, it say there is no friction. Okay. In the question, it say will not have to depend upon friction to prevent the car from sliding up and down. So it means the car do not move here or move here, right? Or it move up and down like that. But again, it's a chapter 2 question. You have a contact on the surface, so remember to pull in the NC. And I already explained why this direction look like that. Because your surface like that. Okay, your surface, like your road is like that, the path is like that. NC is always 90 degree to the contact. 90 degree. So there's an angle there. Then there is a force pulling inside the track with its normal direction, because tangent moving up. Okay, tangent, you move tangent like that, normal like that. Okay. So equation of motion F equal to ma. In this case, we're dealing with normal direction. Okay. Normal direction, in this case, force to the right is positive. So you can derive the force, right? And to this direction, NC sine theta, right? It's split into here like that. NC sine theta, we are dealing with N, so here and here. Your theta is here, here and here is sine. Okay. NC sine theta, and remember, M remains same, AN. In previous chapter, there's an equation for AN. AN equal to V squared over rho. Okay, V squared over rho. And there's an equation to calculate the rho. In this case, the rho is given. Is it given? If not given, then you need to derive. Okay. So you put in the equation. B, in this case, you look at the B go up. All right, B go up. So B equal to FB equal to MAB equals 0 because it stay at that location. So FB is 0. But there's a force in B, right? There's a force in B. Okay. So if there's a force in B or 0 because of there's no acceleration in B, this one 0, but there's a force. There's a force on the object. So NC split into this direction. So you get a cos theta, right? NC cos theta, and this one go up positive. So that's why you get negative here. So from there, you are solving two equations. Eliminate NC, right? So there is a procedure to eliminate the N and M. Okay. So okay, there's one more equation. Okay, this one. You pull this one to here so that you have NC one side, M at right hand side. Okay, you move this one so that you can compare left and right. So you eliminate these two by dividing. So when you have sine and cos, right? Sine and cos, sine divided by cos, you get tan, right? Tangent equal to sine divided by cos, right? So you get tangent. Then you this one you remove, and you get v squared over g rho. Okay, so theta equal to inverse of v squared over g rho. Okay, so this is the question he asks you. Determine the bend angle. So in this case, you ask you to derive the equation. Okay, now? So with this, we stop here. We'll continue chapter 2 next week. Okay. Sign your attendance. If you come late, remember to sign your attendance.